Today I'm going to teach you how to create a broken live CD. I call it that because it doesn't really work properly. You might ask, why am I teaching you this? And the simple answer is just for understanding. As I was learning all this stuff, I made lots of mistakes. This was one of them. We will be making a very minimal ISO that is bootable. That will boot into Linux. It does kind of crash, but we'll bring you a basic shell. And again, this is just more for understanding. We're going to make, since it's going to be so minimal, you'll see the minimum number of files that we're going to be using for live CDs. And I think it'll help you understand as we move in further into creating custom live CDs and remastering live CDs, what's going on if you see the basics. But if you've been watching, again, this is part of a series. There should be an annotation on the screen to the full playlist. A new video every Monday. We've been working with a few ISOs. You can see we're in the folder we've been working with. And we've looked a little bit at the kernel file and the initial RAM disk file. Well, today we're going to take those and we're going to use syslinux, which we'll be using ISO Linux, which is part of the syslinux package, to create a bootloader, and then we will create a live CD from there. And I'll explain a little bit more on why things aren't working as we move along. But for right now, let's make a directory. Let's actually make a few directories here. I'm going to use mkdir to make a directory. I'm going to do -p because I'm going to make a folder with a few subfolders. This will allow you to do that if the folders don't already exist. We'll call it mylive, and then we'll say ISO and ISO Linux. So we just created 3 folders. Let's move into the mylive. This will be where our ISO will be saved in the end. We'll go into the ISO folder. This is the root directory, will be the root directory for our ISO, our CD image. And then we'll have our ISO Linux folder, which is where we're going to put the information for our bootloader. We'll also put our kernel and our initial RAM disk in here. They don't all have to go in here. Again, it's all depending on how you put things together and how you configure them. But I'm just putting everything in this folder, keep the root directory kind of clean, and just have everything in one directory since we're only going to have like 4 or 5 files in here. So now that we're in here, again, there's nothing in here. What I want to do is I want to put a kernel in here. Now in a future tutorial, I'll show you how to compile a kernel, at least on a Debian system. But we're not going to do that today. Today we're just going to copy the kernel that I have on my system. So I'm going to say copy, and your kernel's in your boot directory. I'll just autocomplete here. You can see I have a few because I've upgraded a few times. I'm just going to copy this one to here, and I'm just going to call it Linux. I'm not going to give it any other information. So we have a kernel from my system now in this folder just labeled as Linux. Again, what it's called doesn't really matter as long as you put it properly in the config file. Also note though that my system is running an AMD 64. Depending on what you're doing, if you're going to run on a 64-bit system, that's fine. When we emulate it at the end here, we're going to have to make sure we tell the emulator, the virtual machine, that we want to use a 64-bit operating system. And remember, 32-bit will run on a 64-bit processor, but not the other way around. Well, I think there are ways to make it do it, but not by default. Now, we can also copy from that same folder, from the boot folder, our initial RAM disk files. So I'll just pick the one that has the same number as my kernel, which is 3.10-3, and I can copy that to here like so, and I'll just call it initrd, and it's here. And obviously if we do file, it's going to be a gzip file, and inside that a CPIO file, just like we've been playing with most of the distros we've been using as an example. So that's one way. You could just copy it to there. But you could also, just as another option, I'll remove that file, Control L to clear the screen. And here, like I said, we can run a command. You have to be root or sudo for this. It's make init ram fs. As you can see, it gives you a basic usage thing. And all I have to do is do -o and what we want to call our init ram disk file. So there we go, we did that. Give it a second. It's creating it. And now we have a brand new, if we use file, oops, you can see it's the same thing created today. Control L again to clear. So either way, you can copy it from your boot directory, or you can use that program to make one. There's other options when you're creating one. You can create a config file and give it other options to customize it. So far, though, we have both these files, and the RAM disk is 14 megabytes, and the kernel is 2.4 megabytes. And you could definitely trim this down in size. As an example, like I said, both the shell version of TinyCore and SLTAS are under 10 megabytes. And this is just our initial RAM disk, and where that's their full shell operating system. So anyway, we have our two files in there. We have our kernel, which we called Linux, and we have our initial RAM disk, which we called init.rd. So now at this point, we also need to copy over the ISO Linux.bin, which is the binary for the bootloader. You've seen it in previous tutorials. You can pull that off their website for the ISO Linux.bin. You can also extract it from an ISO live CD you already have. But you could also, you might already have it on your system. You should already have it on your system if you have the syslinux package installed. And I can do a search, and it should be under, instead of searching my whole hard drive, I'll just look under USR. I'll say search for name, ISO Linux.bin. I'll do a search for that, and you can see we have a few copies of it here. So all depending on where how your system's set up. I'm just going to copy this one to here. So now we have 3 files in this directory. Again, our initial RAM disk, now our binary for our bootloader, and our Linux kernel. But the binary, the bootloader, it needs a config file that we've looked at in the past, but we're going to create one now. We'll call it Vim. Well, I'll use Vim as my text there. We'll call it ISO Linux.cfg. And first thing we're going to do, we're going to display a message. So we'll just say display, and there'll be a file called boot.txt. You can call it something else if you'd like, and we'll create that file in a moment. The next line, we're going to say prompt1, and then we're going to say default, and we'll say my Linux. And again, this is going to be the name of the label that we're about to create, so you can call it something else if you'd like. I'll say label my Linux, and then we're going to say kernel is the Linux file. I don't need to give it any folders if it's in the folder with my ISO Linux. So I just have to type the name of the file, so kernel is Linux, and then we're going to append a init RAM disk, and that will be our file, which we called init RAM disk. Again, you can call it something else if you'd like. You can have the extension GZ on there if you want. It doesn't really matter as long as you put in here what you've named the file. And that's it. That's our config file. We'll save that. We do want to create our boot message file because we want to have a nice little message welcoming people. So whatever you put in this file will be displayed when the CD boots. We'll say welcome to my Linux CD, like so. Give it nice little borders there, and we're pretty much done. So altogether we have 1, 2, 3, 4, 5 files. We've got our boot message, which is loaded in our configuration file, which is what our bootloader here binary looks at. We have our RAM disk and our kernel. Let's back out to our directory outside of that where we started, and now we're going to use a tool called XORR-ISO-FS. Now this is a newer thing. If you've read tutorials on making live CDs before, you might see some that use make ISO-FS. program, which may still be true on some systems, but currently on newer Debian systems, that has been replaced with this program. So don't get confused if you're seeing tutorials say other things. If you can't find this program in your package manager, check for make ISO FS instead. I'm not sure I think it's either make ISO or MK ISO FS. Just so you don't get confused on that, because you might be running a different operating system than me. But we're going to say -L -J -no -mul -boot. Then we're going to say -boot -load -size 4. And you're probably going, what does all this mean? And the truth is, I haven't gotten that far myself. I just know I have to type this to make a bootable image. Some of it may not be required, as again, if I don't know what it does, then I don't know if you need it or not. But so far this has worked for me, so this is what I'm sticking with. Okay, but now this part I do understand. This -B is asking where the boot directory is. Again, you could put it in the root directory, you could put it somewhere else, but on the CD it's going to be, we created a folder called ISO Linux, and within that it's looking for this binary. So basically, -B is telling it where the binary is for the bootloader, and we put it in that folder, which will be inside our image. Then -C is another file it's going to create in that folder, ISO Linux -boot.cat. It's probably something you've seen maybe in the folders when we were looking at the other distro images, and that's going to be created with this command. Then we're going to say -O, and this will be the output file. We'll just call it mylinux .iso, and then it's going to ask where's the folder that has all this in it, and of course we created a folder called ISO. It's in the subdirectory from where we're at, and that's it. This is pretty small, should only take maybe 5 seconds. There we go. We'll list this out, and you can see we now have an ISO. Check the size of it. It is about 17 megabytes, so not very big. Could definitely be trimmed down considering it's just a shell and it's not even going to boot properly. Now, again, I started talking earlier about how this is a broken live CD because we created an initial RAM disk based on my system here. We either copied it from the boot folder or used the make initial RAM disk FS program to do it. And those RAM disk images are designed to load and then load a full file system, either off a hard drive partition or some sort of image. Well, we don't have that, so it's actually going to fail, but it will drop us into a basic shell within our RAM disk. So again, you'll probably never actually do it this way, but these similar steps and also just understanding where the files go and what they do is why I'm giving you this tutorial. And we'll make live CDs that work a little bit more proper in the future. Now I'm going to use QEMU. That's how I pronounce it. QEMU, whatever. Should be in your repositories. It is fairly common, but I'm not just running it QEMU and then the ISO because by default the virtual machine tries to run as a 32-bit. Again, we create a 64-bit live CD in this case, so it will fail unless you tell it, because QEMU can emulate all these different processor types from ARM to 32-bit to PowerPC, so forth, so on, and we want x86, so that's just telling it to emulate that processor. And then the only other command we need to give is -cd-rom and the name of our ISO, which is my ISO, mylinux.iso. So here we go. We'll start this up. You can see we got our welcome message that we put inside our boot screen, and now it's just waiting for us to hit enter. And you can see it's loaded the kernel. It extracted our initial RAM disk to the RAM, and it's trying to create some things here, and it will eventually get a couple of errors and drop us into a basic shell. So again, you may never actually do it this way. You may have seen this error message if you had a live CD that for some reason didn't work on your system. But we do have some tools here in our bin folder We got BusyBox, which is a shell that we're working from, which has lots of tools in it, and we'll talk about in a future tutorial, especially if you're working on lightweight systems like ARM systems, like with an Android. You might have a trimmed down version of BusyBox, which you can replace with a full version of BusyBox, which will have things like churroot, which we talked about in I think last week's video. But definitely a lot of tools right in there. wget, WC, you got Telnet, you got FTP stuff. Usually it will have a HTTPD, so you can have a little web server running off this. Also, our initial RAM disk and kernel are very lightweight, so you may not even be able to get online with this, depending on your hardware and whether the driver modules are installed. But again, this is just more for knowledge than actually doing practical stuff. Lots of tools here though, and basic shells. So I hope that this helped you understand a little bit more about how live CDs work. And we're definitely going to, as I said, as the weeks go on, new video every Monday. It's part of a playlist. There should be a annotation on the screen to the full playlist. Again, if you get to a point where you can't access one of the videos in the playlist, it's probably because I haven't released it yet. The next video will be released next Monday. But we will be getting more into, like I said, taking live CDs that already exist and remastering them. Both using tools that exist that automate the process, but we will also, based on what we've learned the last couple of weeks of uncompressing these file systems, we'll uncompress them, go in, modify the file system, maybe do a cross-platform churroot in some cases, or just a regular churroot if it's the same processor architecture that you have. Modify it all, repackage it all up. Repackage the CPIO, gunzip it again, or not gunzip, but gzip it again, and then put that back into an ISO, and then recreate an ISO just as we did in this tutorial, using that XORR ISO FS program. So the process would basically be the same, except for that we would have an actual working file system rather than just an initial RAM file system that's looking for another file system that doesn't exist. So definitely going to have fun remastering those. Also creating custom CDs. We'll do where we will create some based on pulling down file systems from the internet, modifying them, and then packaging them into ISOs. Also, taking your current file system and packaging it up into a live CD. So if you have your system all set up, you could make an image that you could go and then boot on another system off a CD, USB drive, USB hard drive, whatever. So definitely going to be building onto this. Even though this, as I said, fails in a way, it helped us learn the process. So if you have any questions, that's great. Don't put them in the comments below. Comments are great. If you have comments, comment below. If you have questions, my IRC channel is a better place to ask. If you go to my website, filmsbychris.com, that's Chris with a K, should be a link in the description. There should be a drop down at the top for social networking, where you can also get to my Facebook, Twitter, and Google Plus accounts. But there will also be an option there for the IRC channel. Feel free to come in there and talk. Don't expect it to be a help chat line where you're going to get a response right away. It's a place where people talk and learn together. I may not be in there. I try to be in there a little bit each day, but I can't be in there 24/7. So if you come in there, don't come asking me for help. Just ask for help, and maybe someone that's in there will be able to help you, or at least point you in the right direction. Also, I just thank you for watching. Be sure to subscribe so you don't miss any of these videos. And like this video if you're liking these topics on just doing different types of Linux installs and live CDs and fun stuff like that, so that I know that you like them. And I hope that you have a great day.